Good day. I'm Martin Gagel with Market Radius Research. It's Tuesday, April the 25th, and we've got CEO Dan Blondal of Nano One Materials joining us today. Nano One's a battery technology company focused on the next generation cathode materials for lithium-ion batteries. The company just issued a news release outlining the roadmap of the developments of its proprietary cathode production technology and how its recent acquisition of its Candiac facility in Quebec is critical to accelerating its path forward and truly a unique differentiator in the market as the only LFP cathode production facility in North America. Dan's here to dig into this a bit more, but please remember, this is neither recommendation or investment advice. We are here to learn about the company. Dan, thanks a lot for joining us today. Reading this news release, it really seems like Candiac facility, that acquisition, that kind of very fortunate to sort of appear in front of you guys, is really key to sort of jumpstarting the and accelerating the Nano One's business plan from your research lab out here in British Columbia to pilot scale and demo scale pathways in Quebec.
Yeah, look, it was, we had a plan to go into Quebec before the Candiac facility became available, went on the auction block essentially. And we had hired Denis Geoffroy, who was the former general manager of that plant. And actually he helped develop, design, build and run that plant for a good 17, 18 years before he ended up in our hands. And then shortly thereafter, literally like a week or two after that, Johnson Matthey exited the battery space, and we said, "Wow, this is a fantastic way to accelerate the process." So we had all the pieces in place. We were kind of in a way kind of half pregnant on it, and when the opportunity was there, we were able to present a very viable bid to get that facility. It helped a lot by the fact that we had the former general manager of the plant who knew everyone there and had a lot of really a lot of credibility with the team. And that enables us to, we kept everybody there, like 100% retention from the time Johnson Matthey announced it to the time we ended up closing the deal on November 1st, 6 months ago. So very lucky in some ways, but also kind of part of a larger master plan.
Yeah, you were ready for it when it came up. You obviously saw the opportunity and were able to jump on it and sort of fully seize that opportunity. So this news release, it really sort of outlines a path forward. And I think one of the things that maybe people don't quite understand with technology, especially high volume technology, chemistry for the automotive industry, its scaling is a huge issue, where what works in the lab maybe works on like bigger scale, but you have to tweak it. Your clients, your ultimate customers have to be very confident before they put their supply chain in your hands that it really works. And you've kind of got the stepping stones here to show them that you can do that progression forward and provide them a good, reliable product as advertised.
Yes, that's correct. And it starts, obviously it has to start at the lab scale, literally the gram or 100-gram level. You move to kilograms, which is kind of where we are in Burnaby. That's typically where we pilot to. And we use those materials go out for evaluation and demonstration and a variety of other things that are really part of our business development efforts. But then ultimately you have to prove them at larger scales. You start to have to get into the ton scale, the tens of tons, the thousands of tons, the tens of thousands of tons. And at each one of those levels, there are tweaks that have to happen. And as the equipment gets bigger and bigger, obviously the costs get bigger and bigger to make tweaks. So it's important to really kind of fine tune those changes early on as possible, and at least have the platform to go back. If you're going to make a tweak, well, I'm going to go back to the smaller equipment, test it out there before I've got the confidence to move it forward to the next one. And that's kind of the game you play, as you ratchet up your sort of manufacturing technology, and as you try to bring on especially automotive partners. they need to be sure that if they're going to buy into your program, that you're going to be able to supply them materials well into the future. And it's not just the manufacturing platform; it's also the supply chain. We've got Rio Tinto obviously as a backer and a potential supplier of iron metal powders going forward. That is at the crux of lithium iron phosphate, is where the iron comes from. Even though it's the cheapest and least expensive component in LFP, it is really the most important part of the lithium iron phosphate is where that come from and how you access it. There isn't a lot of battery grade iron out there, and identifying the sources of it in various jurisdictions is super important. China, they do it differently, and in North America, we're going to have to use different supply chains to make it secure and long lasting and certainly palatable for the large OEMs.
And when you say the iron has to be certain to battery grade quality, is that with impurities in there or just an absolute high purity level of it? Or what makes that kind of iron special?
So battery grade is really a reference to the impurities, and you can't have impurities. There are bad impurities that can happen inside a lithium-ion battery. If you've got iron metal floating around in there, or copper or anything conductive like that, it totally messes up the battery.
Yeah. And
so all of it has to be either get converted into a ceramic, like an oxide material, which is or a phosphated material that, so it's key that you don't have any of those extra impurities around. To just give you a sense of this, Rio Tinto, just north of our plant in Candiac in Sorel, in Quebec, they make 250,000 tons of iron metal powder there, and it's all class 1 automotive grade powder. Those powders are used actually to compress and sinter into automotive parts for drivetrains and various other applications. And so they're already kind of automotive approved. They're already part of the automotive supply chain. So that makes them really quite unique. You can't say that really about many other battery materials. They just don't, the fact that there is a proven high volume, large source of class 1 automotive grade battery metals able to go into LFP sitting right in our back door in North America is extremely unique. The fact that it's done under hydroelectric power, the fact that it's a metallurgical process and has no waste stream makes it greener and cleaner than any other supply chain in the world as well for cathode space, for the cathode materials. So that's really one of the big advantages, and I think one of the things we can do in North America that will differentiate us from China largely, who have 99% of the world's market in LFP. We can be cleaner and greener and less costly and less complex than the processes they currently use.
Supply chain, obviously, for the last few years has been a big issue and a lot of headlines on that. And in the battery automotive space, I guess there are two aspects to it right now. Is just automotive companies all companies have to review their supply chains, and not just that they're the most efficient, but that they're robust as well, they can handle hiccups along the way, and they want to sort of near shore them so that they have a lot of control over it. Obviously, there's geopolitical issues with China, but then recently last year with Biden's Inflation Reduction Act, with so many incentives with North American produced and US produced components and ingredients for it, that's a new element that's been added to the value of having North American production of this. I'm not sure what my question is, but I guess, is that kind of a right way to look at it?
Yeah, for sure. I mean, I can give you kind of what our take is on it, and it's a complex piece of law they're trying to put into place, and it's still nascent. So it's still being formed and defined and changed as we speak. We've been invited to sort of comment and try to right size it and influence it for the betterment of North America. And so we have some kind of good insight into how it plays out. And I think the key here is that by basically making credits available to any battery that's made with North American or at least friendly sourced critical minerals and any battery components that are made in North America. That goes a long way to onshoring and friendshoring much of the supply chain. The cathode materials are still a little bit undefined, but we obviously have a very good play in North America. We think our LFP product out at Candiac can be probably the most compliant IRA battery materials in North America, and pretty quickly, because of ready partners like Rio Tinto, and because we have the only LFP production facility in North America with the most experienced team in cathode manufacturing ready to go. So that gives us a huge head start, and really it becomes a platform for the launching of our strategy. To go back to your ask about scale, it's obviously it starts small. We're thinking very big. We have to move fast. To do that, we're using the existing plant in Candiac as a very large piloting facility, and we will have it sort of back up and running with newly installed reactors that are basically compatible with the one pot process. All of that should be sort of up and running at the end of this year, starting with a modest volume of about 200 tons per year and moving up to 2,000. And then, well, that becomes the proving ground for much larger facilities, demonstration facilities. We hope to site them on the same land in the adjacent piece of property that we own in Candiac. But it doesn't stop there. That again is still just a proving ground for even something much larger. That's another 10 times larger, into the hundreds of thousands of tons of material. And that would likely take place in possibly in central Canada, possibly in Quebec. But also there's opportunities to site those kinds of facilities in the US, other places in the Americas, and of course Europe and the Indo-Pacific region.
Canada recently passed or the budget, and then there was recent news, I believe that was last week or very recently, with Volkswagen setting up their facility here in Canada. It looked like there was a bidding war, so to speak, between US and Canada on that. This is becoming very strategic, and Nano seems to be well positioned. Quebec has a very strong battery critical minerals, metals strategy in place. So again, I'm not sure what the question is, but you seem well positioned in this to add a lot of value.
Yeah, look, we end up being probably one of the only homegrown cathode players in North America, and I think that so we've been thinking about it longer than anyone, actively in the U.S. and the Canadian markets, and so that puts us in a very central position here. We believe that the cathode material is a really strategically critical part of the supply chain, not just because it's what makes a battery work, but because it defines the supply chain. So the way you make cathode, the way we make LFP is different than the way they do it in China. That allows us to define a different source of iron and different sources of lithium if we want. And the same would be true for any kind of nickel, manganese, cobalt based materials. And by doing that, we can tip up a supply chain that completely eliminates the sodium sulfate waste streams that are associated with Chinese production of both of those materials, LFP and NMC. We eliminate extra refining steps in the supply chain that aren't directly within our fold of manufacturing, but fit between the miner and cathode. And we can do that in a way that makes it.
So sorry, Dan, just the way your process works is some of the other elements and metals and minerals that go into the battery, they can be produced in a less expensive or greener manner using with your process in there. So it makes other parts of the supply chain more efficient, call it.
Correct. Yeah, more efficient and cleaner and greener and stuff like that. So the key is that it's the process. It's how you mix lithium, nickel, manganese, and cobalt, or how you mix lithium, iron, and phosphoric acid to make these cathode materials defines the form that the lithium and the nickel and the cobalt come. It's a bit like having lithium hydroxide and lithium carbonate. There's also, there's nickel metal, there's nickel, there's MHP, which is mixed hydroxide product in the form of nickel. There's nickel sulfate. All of these there's nickel in every one of those.
Yeah.
And the process that uses them kind of defines which one is the most efficient.
Yeah.
And so what's really critical here is that we need to develop the cathode manufacturing space in North America if we are truly to control the supply chain. If we allow that to happen offshore, we let offshore entities, be they competitive or even geopolitically distasteful, they will ultimately control how miners end up having to convert their materials. And if we develop something that's North American or European based, that is based around the available supply chain, we can then differentiate it and make it much more efficient, not just from a cost point of view, but also from an energy intensity, environmental waste stream point of view, water usage. All of those things are super critical to defining the supply chain and making it available. We can't just copy and paste how it's done in China. Partly because there are lots of inefficiencies, partly because our supply chains look different. Our sources of iron and nickel are different, and so we have to kind of customize it. And if we don't, we'll be beholden to the manufacturing technologies that are used offshore. And that's really a big part of our mandate, is to try to put these technologies in place that will make our supply chain kind of long lasting and sticky and resilient. And at the end of the day, sustainable well into the future.
All right. We talked about scaling and going from pilot to commercialization and so forth. Can you give us just a rough time frame as to, like, it's still a little early to give like precise dates, but what kind of time frame should people be looking at where key scaling events happen?
Well, as we said in the news release, we will be installing these new reactors at Candiac shortly. We'll be getting them before the end of this quarter and starting to commission them in Q3. The idea, by the end of Q3, we should be capable of approximately 200 tons per year. So that's kind of end of this year. We'll have most of that in place, and that'll allow us to then sample out our materials, do internal validation work, but also start to do external validation work with our partners, with the object of getting to some kind of an offtake, perhaps some very early revenues, and then we will from there scale with progressively larger reactors, getting that particular facility up to about 2,000 tons per year. Can't give you exact dates on that because we haven't finished the procurement on reactors, and there's all kinds of long lead time items that have to be put in place, installed. But we will know more about that sort of I'd say through mid-year, and then really the finishing touches on some engineering work on a larger facility. 2,000 tons a year is a great pilot, but it's not nearly big enough to demonstrate what we need to do. We need to go to 10,000 tons to fully demonstrate what a production line would look like in an automotive plant. You'd need 5 of them or 10 of them to run a really big plant, but it becomes the kind of the cornerstone, the building block, the blueprint for sort of a turnkey expansion strategy that would allow us to just duplicate that line in various facilities, around the world, or maybe right here in Canada, if we play our cards right. Okay.
All right. Well, your news release covered a lot of issues. I think we hit most of them in here. For those interested, I suggest giving that news release a read. Before we wrap it up, any sort of highlight comments or anything to put a bow on this, Dan?
Yeah, and look, I think everyone always asks about catalysts, going into the future, and I would say I've kind of painted for you how we're planning to do our expansion, how that feeds into our business development opportunities. But look, we continue to explore collaborative work and partnerships with other players. So I think you can expect to see more of that from Nano One in 2023 and beyond. as I alluded to before, we've got a seat at the table with the Canadian government and the provincial governments on critical minerals and battery supply chain, and we're also starting to get some traction in the U.S. as well. So I think that's another you can expect to see ongoing support from both from kind of all levels of governments in North America to drive part of the narrative that we're bringing forward. We have a very unique narrative in the sense that we are trying to do something that is for the better of North American supply chains and is wholly competitive. So that will drive a big part of our narrative going forward, and we think it will help bring many of our strategic partners forward as well. So that again, hopefully we can bring you more news, more details, more names on that in the months and quarters to come.
All right. Thanks a lot, Dan. That was a great update and good insight into the business and just the whole industry on how complex and how complex it is. Thanks a lot.
It definitely is. Thanks, Martin. I always appreciate it and look forward to the next time we chat.